Chapter 3, Matter and Energy. Everything that you can see in this picture of a room on the screen, in the room that we are sitting in, is all made of matter. Different kinds of matter have different properties, and those different properties come from differences in the molecules and the atoms that compose the matter. So this section is titled, What is Matter? Which is a very different question than what is the matter, right? We're not talking about what's the matter, what is matter? Matter can be defined as anything that occupies space and has mass. Now, some types of matter are very easy to see. Can anybody give me an example of visible matter? The desk. How about the wall? Is that made out of matter?
Yes.
Yeah. Come on, one more. The floor. Okay. We're focused on furniture and architecture today. Other types of matter are impossible to see without magnification. What's a sort of matter that is present in this room, but you can't actually see it with your naked eyes? Pardon me? Oxygen. There better be oxygen in this room, right? Or we're all going to die really soon. What else? Do you think there's any bacteria in this room? Yeah, probably. There's people here. Bacteria are made up of matter. You can't see them with your eyes, but they're made up of matter. They occupy space and they have mass. It's a very tiny amount of space and a very tiny amount of mass, but it is a finite amount. Matter appears smooth and continuous. If we look at this bench or you look at your desk, it looks like it's, pretty smooth. It's just one piece, right? It doesn't look like it's made up of little tiny beads or anything, right? It looks smooth and continuous. But matter is composed of atoms. Atoms are submicroscopic particles, incredibly tiny, and they are the fundamental building blocks of matter. Have any of you been to Legoland? Yes. Legoland is awesome. I didn't think of it until just now, and now it's too late. I should have pulled up a picture from Legoland. They have the Taj Mahal made out of Legos. And it's 8, 10 feet tall maybe. It's much smaller than the real thing. But they have Mount Rushmore. They have the White House. It's incredible. But when you look at those buildings, you see they're made out of individual Lego bricks. If you stand back, though, if you get far enough back, they almost look like the real thing. So all matter, the desk you're sitting on, even your body, is made up of a type of Lego brick, really, but they're atoms. So I use a lot of analogies between Legos and atoms. We've been collecting Legos in our house for 22 years or so. We have quite an impressive collection. They end up everywhere, and I've stepped on a lot of them. So just like Legos, atoms can be attached to each other to form molecules. So when two or more atoms are bound together, they form a molecule. And they form those molecules in specific geometric arrangements. They're not random. It's not like glopping clay balls onto each other. They're put together in specific ways. So all matter is ultimately composed of atoms. Here's the top of a soda can, an aluminum can, and if we were able to zoom in and see what this aluminum is made of, we'd see something like this. We can't do that, and so we have to use our imaginations and not just, this is what we think, but experimental data, okay? And so from all of our investigations, our best theory is that atoms are shaped somewhat spherical. So in some substances, like aluminum, the atoms exist as individual particles. So we just see individual aluminum atoms, and they're all nestled together to form the top of this aluminum can. In other substances, they form molecules. Okay, first of all, before we can go any farther, I have to ask you, does anyone see the typo, the problem in this picture from the textbook? So what does this little caption say? Isopropyl alcohol. And what does the label say? Pure ethyl alcohol. Those are not the same. They're similar, not the same. Why? Okay, I got that on my system. Okay, so these are actually pictures of, what is that? 1, 2. I think this is actually pictures of ethyl alcohol. So, there's just multiple problems here. But we've got a carbon, I'm sorry, that's the oxygen. We have an oxygen and a hydrogen, and here's a carbon with 2 hydrogens and another carbon that has 3 hydrogens on it. And my pointer's gone crazy. Instead of existing as individual atoms here, we have molecules. So some substances exist as molecules. We're having a technology freak out test here. I don't know what's going on, but it's still recording. Fabulous. It's reconnecting. This is apparently one of those days where the universe is out to get me. So I apologize if it accidentally falls on you just because you're close to me. Okay, continuing on. This is a scanning tunneling microscope image. This is the best sort of a picture that we can get of individual atoms. This is not an optical image. This is derived, I don't think I have a picture of it now. This is derived by taking an electron probe and running it over the surface and keeping the current constant, and it causes the probe to go up and down, and so then we get this image. It's distorted, and so they look like little cone heads. That we actually believe that they're spherical, but this is the best image that we can get of individual atoms, and it is evidence that atoms actually do exist. This is an image of a DNA molecule. Most of you have probably heard of DNA. This is where all your genetic information is stored, and DNA has this classic double helix structure, and if you look carefully here, you can actually see the double helix in here. Tell me that is not cool. This is a picture of DNA. What? Yeah. Double-stranded structure is visible using scanning tunneling microscopy. Pretty cool. This is matter. Your DNA is composed of atoms. Atoms bonded together into 2 ginormous molecules.